is location? Well, what we have here is a fellow who asked a question related to distance the other day, specifically distance traveled. And he asked this, or he essentially tried to define what distance traveled is. He says the distance of a moving object relative to the medium it's traveling through. Okay? An airplane uses air to measure its distance traveled just as a boat uses the water it floats in. Okay, so what was my reply to this? Well, I'm saying that physics doesn't deal with measurement and with distance traveled, okay, especially when it's a numerical value. And so this was my answer. I said, in physics, we don't measure. In physics, we explain. It's math that measures and introduces numbers and units. Okay, that's why it is absolutely necessary to define what physics is about before we begin to do physics. It is the mathematicians, okay, which took over physics since the days of the Greeks, that veered the discipline in the direction of math. This is the reason not a single mathematical so-called physicist ever figured out qualitative stuff such as mechanisms and causes. It's not part of their job description, even to this day, by the way. Yeah? And yet, why did they attempt to provide a physical interpretation to their equation in the first place? The answer is because otherwise their equations are irrelevant. Okay? If they're going to do measurement and then they're going to do an equation that somehow reflects those measurements, so far they have done absolutely nothing that is of any concern to science, specifically to physics. They haven't done anything that's of any importance to physics. In physics, we need to explain the cause, the mechanism. Once we explain that, we're done with physics forever. Physics, science is not an ongoing process of discovery. No, we stop and we explain. If you can't explain, you're not a physicist. Get out of the way. Okay? You're bothering us. You're in the way of progress. Okay? You need to explain. And once you explain, we're done with physics. We're done. Okay? You got a better explanation? Great. Bring it on. Okay, so how do we start this thing where we ended up with distance? And before that, I discussed position and what is it? Place. The word that the Greeks used. And so I started out with a little summary of what happened in the days of the Greeks. They weren't the first, by the way, but they did document what they thought about all these things, okay, especially about positions, which a lot of people equate with location today. So let's make sure we cover, the steps that led to that notion that position and location are the same thing. And it started with these Greeks, okay? We had the Eleatics there on the upper left. And they said that everything is immovable. There's nothing that moves in the universe. Why? Because, there is no such thing as an empty space in which something can move into. Okay, so that was the issue. So they said, there's no such thing as empty space. Everything is covered. When you move something, something else moves in there. But the only way it could move in there is if you had an empty space. And they said that's impossible. So they said there is no motion. That was their conclusion. What did the atomists like Democritus and Leucippus come up with? Well, they said, there has to be some space because there's obviously motion in the universe. And so they treated these other folks as idiots. They said, no, these people are saying there's no motion. What do you mean there's no motion? I'm moving my hand right now, What the hell are you saying there's no motion? Plato thought that matter and space are the same, okay? And so he said the participant and space are identical. So he thought that space was a thing, okay? And that matter kind of displaced space, the emptiness. And what did Aristotle come up with? Well, he said the existence of place is held to be obvious from the fact of mutual replacement. Okay, you can replace something in water where air was, for example. Okay, what now contains air formerly contained water, so that clearly the place or space into which and out of which they passed was something different from both. So he thought there was something. He called it existing. That's the adjective he says. It's space. This emptiness exists. It's a thing. Even though he said that in order for something to exist, it has to have location. And so he said space exists, and I don't know what the location of space is, but he never answered that question. He just said it exists, and because it exists, something can move into space, into nothingness. Okay. So that was his conclusion. A few hundred years later, we have these three other fellows. I talked about them in the past, so I'm not going to go over them in detail. Okay. One was Newton, and he said place is a part of space which a body takes up, and is according to the space either absolute or relative, okay? And he believed in absolute space, and I guess it was Einstein who turned that over and said, no, it's all relative, okay? Positions properly have no quantity, okay? Nor are they so much the places themselves as the properties of places, okay? So he started bringing numbers into this where I don't even know what quantity has to do with position. Shouldn't have, but you'll find out why in a minute. And a short time later, less than 100 years later, we have these two fellows, Hume and Kant. And Hume said, space does not exist independently of objects. cannot conceive of space in the absence of objects. Okay, so this was his notion. So, again, they were all trying to figure out space and, again, position, I guess, location of things in space. Okay, and what did Kant come up with? Well, he says you can't imagine the absence of space. So the first guy said you can't imagine the absence of objects. This guy said you can't imagine the absence of space. Okay, and so he thought about in terms of infinite space again. He thought it was some kind of object, and he said, well, it's better not to even think about these things because we're not going to solve them. Okay, and yeah, I think we can solve them if we define what space is, and once we define space, then maybe we can talk about position and location. Okay, so that's the way it works in science. And these people never defined space, and they started talking about space without really defining what they meant by space. They just wondered whether it's an object and whether it exists. But they never started at the square number one, which is, please define the word space if it's a concept, and otherwise point to it if it's an object. What is the shape of space? If you can't point to it, then it's a concept, and you got to define it. And so they never did either. So they didn't start at square one. That's why they never figured it out. And we're talking about there at least the 18th century. Okay, did we do anything better since then? Well, then we really made a mess of things. And here we have the relativists. And they said, look, we're going to be doing length contraction. We're going to contract space. Okay, we just need to make that thing travel at the speed of light or close to the speed of light. And you'll see how it contracts. Okay, like an accordion. And what did the quantum folks come up with? Well, they said space is made out of particles. Okay, it's got all this junk in it. One fellow called it the Dirac sea in his own name, Paul Dirac. And they say that particles come out of the vacuum. Okay, in other words, a vacuum is made out of particles that can come into our world. They're known as virtual particles momentarily. Okay, they come into our world momentarily, these virtual particles, and then they go back to being part of space. In other words, they think that space itself is made out of particles, meaning that somehow they equate this with an object, with a thing. They're saying space is a thing. And so you can see the trouble this is going to create for both position and location, because how can you say that you have a certain location if what you're doing is taking over the spot occupied by particles, I assume? Are you displacing the particles aside and occupying what? Nothingness? If nothingness is made out of particles, what are you occupying? Are you displacing the particles that make up space? And if you travel close to the speed of light, are you shrinking or taking up more space, taking up less space? What are you taking up if you haven't defined what space is? So again, we have a problem because none of these people ever defined words. What was it? What I said earlier, I said that, one of the first words you have to define in science is the word definition itself. You need to know what a scientific definition is. If you don't define the word definition, then you can't even start. Because you don't know what a scientific definition is. You're just going to go to the ordinary dictionary, pull a definition out of there and say, I'm going to bring this into science. It sounds good to me. Well, if it sounds good, be able to defend it. That's the way it works in science. If you can defend it against all attacks, then you have a definition you can use. Otherwise, you can't use that definition in science, especially for the foundations of science. Okay, so what is position? Well, position is essentially a game of battleship. That's what they think it is today. Okay, position is like a portion of space where you're going to put a dot in there. Okay, you're going to put not even a dot. What you really are putting is an ordered paired or triplet or whatever, quadruplet. You're going to put a couple numbers that designate how to get there, how to get to that spot. It's not the spot itself, but how to get there. Okay, so they have a series of numbers. They say, it's like battleship. You have H1 versus A8. And you put a dot there. You put an X or a dot. If there's a battleship there, well, you put a dot. If you have water there, then you put an X. Great. It's the game of battleship. That's all it is. Okay, and so what is a position under this notion, this definition, or this way of presenting things in mathematical physics? And here it is. It's essentially how to get to the treasure chest. Okay, what you have is, in those two numbers, if you're using an ordered pair, what you're saying is not the position of something. What you're saying is how to get to that position. You're giving a set of instructions of how to find the treasure chest. Okay, that's what position is under mathematics. Okay, so here we have the way it's represented. They use the dot to represent position. And again, what they're doing there is something which is irrational. They say that a position is defined, or is what they're going to use is an undefined point. They're going to say, we're going to put a point there. Well, what's a point? Well, a point objectively is what you see there. It's a dot. It's got shape. Okay, so it's an object under the definitions of physics, under the definitions of science. A dot is a thing, okay, because it has shape. That's the only reason. And but a position is a concept. If you take it as how to get there, that's a concept. Now you can use something else, like you can say, well, what if I take the center of mass of the elephant? What you want to do is locate where that center, the elephant is an irregular shaped thing. Okay, so the center of mass is not in its trunk or in its feet; it's somewhere in its body. And so you want to say, what's the center of mass of the elephant? And there, I'm going to put a dot, I guess. But what are you saying? You're saying how to arrive from a set of coordinates, reference frame, okay? Frame of reference. From that frame of reference, you're going to say, this is 0, this is my starting point, and I'm going to go so many meters to the right, maybe on the x-axis, then so many upwards, and that's how I get to the center of mass of the elephant. And you put a dot there, and you say, okay, that's the center of mass of the elephant. Again, it's how to get there. It's not like, I mean, how else, what other notion, what other definition could you have then for position of the center of mass, unless you relate it to some frame of reference and use, in this case, the x and y coordinates to get there. There is no other meaning to that. Okay, so position is, how to get there. It's not the dot itself that you're representing, in this case, the center of mass of the elephant. What you're saying is how to get to there, to that place. Okay, that's what this has become. Okay, so what happens? Well, if that's what position is, okay, is that the same thing as location? Are we locating something, or are we talking about the position occupied by either the elephant or the center of mass of the elephant, which makes no sense whatsoever because it's a concept. You can't say what is the position of the center of mass. Well, you can only tell the position if you have an XY coordinate system and you say so many feet this way, so many feet that way. But if you just put a dot there, what is the meaning of that dot? Okay, it only has meaning if you put a set of coordinates. Okay, and so this is the situation. Is position the volume occupied by an object? Are they synonyms? The volume itself, occupied by, I don't know, the pencil? Is the pencil the same thing as the position, the volume it occupies? Or is the position the steps necessary to get there, to reach the dot or whatever you represented the pencil with? Okay? Because if it's the steps necessary to get there, then it's a dynamic concept. Okay? You're talking about displacement. You're talking about motion. Okay? Meaning position, which is a static concept, or in the minds of most people, it's a static concept, is actually motion. Because what you're saying is, I'm going to give you the set of instructions of how to get there. Take this road this way, so many miles, and so many miles that way, and you'll reach the treasure chest. That's what you're saying. You're giving them a set of instructions on how to get there. So it's not the volume occupied by the treasure chest, it's how to get to the treasure chest. Okay? So how do we do it in science? Well, first of all, we distinguish position from location. Okay? And the way we do it, we have to define them. So position is the volume occupied by an object. It has no importance in physics because it's the object itself. Okay? And we have no use for numbers. Okay, don't tell me how many steps to get there because it's irrelevant to the issue that we're trying to resolve here. Mother Nature never went to school. She doesn't know anything about math. She's ignorant completely in numbers. Mother Nature just works with objects every day. She moves them around from one place to another. That's all she does. In fact, she doesn't even do that. What she has really is every frame of the film is what Mother Nature does. Location. That's all it is. An object at a given distance from all the others in the universe. So Mother Nature lives what we can say in the now. Now meaning just a cross section of time, not an interval of time. I don't care how small you want to make it. An interval is many, many frames, no matter how you look at it. We're not talking about many frames of the movie. We're talking about a single frame of the universal movie, a cross section of time, so to speak. Whatever's in there is static. Nothing is moving. All we have is distance between objects. We call that location. Mother Nature only understands location. She doesn't understand numbers. She doesn't know anything about meters, and she only knows about separation, which was the distance between objects, separation. Distance traveled, no. Mother Nature doesn't understand that either, especially if it's numerical. Okay? Because for that you need several frames of the film. Okay? And Mother Nature just lives at the cutting edge of the past, you could say. Right where the past meets the future, we call that the now. The now is not an interval, even though, it's you could think of it as an interval of time. But no, the now is the cutting edge. It's a cross section of time. It's a single frame of the universal movie. Everything is static there, and that's the only thing Mother Nature understands. So location is qualitative only. What is it? Well, in order to get to the definition of location, you need to have these words defined first. You need to know what an object is. Without objects, you have absolutely nothing in the universe, meaning you only have space, which is nothing, which is that which has no shape, so you can't, nothing is happening, nothing you can measure for sure. There's no distance, no location, no anything, because you need the object to have any of those properties. Once you have the object, okay, now you have distance. What is distance? Distance is just separation between objects. You don't unroll the measuring tape and say it's so many meters. That's not distance. That distance traveled by the tip of your measuring tape. We're talking about only separation between the centers of the object, the surfaces, whatever you want. Doesn't matter. That depends on you. But it's separation. Once you have separation from this object to that object to all other objects, then you have location. Now you have the set of distances, the set of separations from one object to all the others. So far, these three words are static concepts. They only have relevance in a single frame of the universal movie in a cross section of time. That's location for you. Okay. So, forget about this notion of position. Position, especially if position means motion, synonym of motion, saying that, it's how to get there. That's walking, that's running, that's flying, that's swimming. Those are verbs. Okay, so position is how to get there. You're not talking about a static concept, and for sure you're not talking about position. Position, anybody's idea of that, at least in ordinary speech, is that it's a static concept. And these people transformed into a dynamic concept, but we already have a word for that. We call it motion. So what is this position nonsense? And even if you're going to put numbers to it, we call it displacement or, distance traveled. So what is position? Again, no meaning whatsoever if you just put a pair of, ordered pair or whatever, X, Y.